All right, last level of boot camp. We are about to graduate from equations boot camp. This is the only thing in your way. That's level 10, the general level. Percent and percent of change. So we got two learning targets. One is to find percents in general, and one is to find percent of change. Thinking of at a store where you're looking for some nice shoes and they're 30% off. That would be a 30% change, 30% decrease. So we got to figure out, um, well, if you know the prices, what's the percent that it's going to change. So a couple things for success criteria. You got to know the percent proportion. I'm going to really focus on that for solving percent problems. Also know the percent of change formula. So let's talk about that. And then realize that we're dealing with formulas. So plug and chug, plugging in for variables and working it out from there. Those are big things. So let's get us started with one vocab word, since it's all about percents. What is a percent? A percent is simply a number out of 100. So as you're writing that down, a couple things to review with that. If I were to write 60 out of 100 as a fraction, that's the same as 0.6 or 0.60, and that's the same as 60%. So reminder, if we're going from decimal to percent, you're multiplying it by 100. And the trick that you may have learned before that moves it two places, the decimal two places to the right, you add in a zero and it's 60. All right. Let's say you're starting with 22% and you want to write it as a decimal. Well, we're going to go backwards. Let's move the decimal back. It's dividing by 100. You get 0.22. That's also 22 out of 100. Let's say you're starting with well, there's two good examples from going from fractions to decimals to percents or backwards. That's what a percent is. It's just a number out of 100. It's a commonly used number out of 100. So let's talk about percent problems real quick. This one says a dress shirt that normally costs $38.50 is on sale for 30% off. What's the sale price on this shirt? So we got to figure out what 30% off of 38.50 would be, and then we can subtract it from 38.50. So that's one way to do it. Um, so I'm going to show you two different ways to solve percent problems like this. Both are useful in different. Well, one of them is useful in one situation, and the other one is useful in all situations. I'm going to show you both anyway. The first option is the percent equation. So when I get an example like that, I right away actually would use the percent equation because I can do that quickly, like just in my, well, not in my head, but in a calculator quickly. The percent proportion, um, essentially, if we're looking over on the left here, is take the percent as a decimal. So in this case, I would be taking 0.3 multiplied by the whole. So the whole would be the normal cost, 38.50. And we'll get our answer as to what the cost is, the part. So that part that you're taking off. So I'm just going to take my calculator and show you what I would do using this percent equation. I would do 0.3 or 0.30, whatever you want to write for 30%, times 38.50, and I get 11.55. That's the part. That's the part that you're taking off of this, 11.55. So with that, I would then subtract 11.55 from 38.50, and I'll get my sale price. So 38.50 minus 11.55, and I get 26.95 is going to be my final cost. Now, the second way you could solve something like this is to use this percent proportion. Now, I'm going to strongly encourage you to use this one because it'll work for all different ways that things are written. Whether you have the percent, or you're trying to find the percent, or you're trying to find the total, or you're trying to find the part, it'll always work. And there's really three things you need to plug in for this proportion. The proportion is over of equals percent over 100. Um, so I think I'm going to wait for this one to show you. Well, I'm going to show you right here with example one. Percent proportion is over of. So what I mean by that is something is out of something. So Normally, when it's of, that's a total, and is a part. So it's kind of like a part over whole equals percent over 100. So if I look at the is 2.5, that's the top. If I look at the of, that's 40. That's the bottom here. That's the denominator. Equals percent. Oh, this is always 100. We don't know the percent. We're trying to find the percent right here. So that's going to be our x. So I'll put x right here. Nice thing about that is it's a proportion that we can then cross multiply to solve. And you know how to solve proportions. So 2.5 times 100 actually gets you, moves the decimal two places over, so that's 250 equals 40 times x, which is 40x. Divide by 40. I get an answer of x equals 250 divided by 40. 6.25. So 2.5 is only 6.25%, because we're trying to find the percent for this one, of 40. Now, we did this example already with the percent equation. I'm going to show you with the percent proportion as well, because it works as well. So if I know 30%, so I've got is over of equals percent over 100. My percent is 30, that's for the sale, out of 100. Is over of, so 3850, that would be the of. So that's the tricky part. That's the whole. It's got to be on the bottom, 3850. So we're trying to find what part of that would be on sale, or what part of that would be taken off, I suppose. So we got 100x equals 30 times 38.5, or 3850. 3850 times 30 is 1155. And when I divide by 100, I can do that for most things without using a calculator. Because like we said, if you're dividing by 100, you're moving it back two places. 1, 2. So really it's 1155. That's how much is taken off, which is what we found above as well. We got 1155 was how much was taken off, and then we can subtract it from the total to get our final cost. But the same amount of steps. The benefit to the percent proportion is it'll always work. The percent equation can always work depending on how you use it, but it's best for certain situations when you have the percent and you have the whole. That's percent problems. Now we're going to go to a percent of change example. Percent of change, you may have learned before. It's an example where you have $100. Um, let's just say there's $100 video game that goes on sale for $70, and you want to figure out what percent you got taken off. That is an easy one. That would be 30%, but they're not going to all be as easy as that. So one thing I want you to remember is no. Yeah, I said it. No. NOO. It helps you remember the percent of change formula. New minus original over original. NOO. So how that's used. Let's look at this example. It says the coat is on sale. The original price is, all right, original is 82. The sale price, so that's the new price, is 74.50. What's the discount? So new, we're going to put in 74.50. Original, we're going to put in 82. All divided by the original, which is 82. 74.50 minus 82 is 750. Sorry, negative 750 over 82, and you'll get a percent when you divide out. So um, we get 750 divided by 82, and we know it's going to be a negative. So I get about, I'll round it to 0.09. Or that is also 9% And what do you think it means if it's a negative? Well, that just means that it's a decrease. So it's a 9% decrease in price. So the price went down 9%. Maybe not as good of a deal as you thought, but I'll take 9% off anything. Let's do one more example like that for percent of change using that formula no. So we've got a store buys an electric guitar for $295. The store then marks up the price, so the new price would be $340. That's the new price. This is the original. What's the markup expressed in a percent change? So let's plug in for the n minus o divided by o. So new 340 minus original 295 divided by the original 295, which changes to 45 over 295. And if I divide that out, I'll get a decimal, about 0.15 if I were to round it. And it is a positive. So to change that to a percent, multiply it by 100, so it's out of 100, or move the decimal over. But it is 15%. That's an increase. It's a markup. It's positive, so we know it's an increase, but it also said it was a markup in the price. So that's the percent of change. So we got two different concepts here you got to have notes on, the percent of change and then also originally the percent problems with percent proportions. So we're going to do one of each that are from the homework. I'd like you to actually pause it here. I will work them out, and when you unpause it, you can see how you work them out and see how you can your work compared to this. All right, so if you work them out, I have the formula for the left one. That's a percent problem. I have the is over of equals percent over 100. So I took the percent proportion. So I've plugged in the 21 is the is, because the 35 is the percent. So I plugged in 21 for the is and 35 for the percent, and we don't know the of part. So it's 21 over x equals 35 over 100. When you cross multiply, you get 35x equals 2100, and I divided by 35 to get x equals 60. Now for the second example, number 6 here, the percent change formula is that no formula. So new minus old over old, or new minus original over original. So I put in 30 for the new, minus 25, all divided by 25. That ends up being 5 divided by 25, which is 0.2. And that's a 20% if you change it to a percent. And that's positive, so it's an increase. So there's some examples of percent and percent change. And that's revisiting our learning targets from today to find percents and to find percents of change. Those three success criteria are so important. Knowing that percent proportion will always help. Knowing the percent of change formula, and then plugging and chugging and working from there. So I hope you learned something here, generals. Hope you can move out and move up and finish the equations boot camp. Enjoy the rest of your day, soldier.